Thank you, Keith. It's nice to see so many of you here, and I know it's the end of the day. You've had a lot of technical talks today. I've also kind of felt like I've learned so much today that during the day I thought, okay, I need to adapt my slides, my talk, so we'll see whatever comes out now. I'm going to give you a kind of overview of ASML's Julia journey, and I think many of you might recognize elements, and hopefully I can also add some new kind of things for you. So I will quickly go over who ASML is and what we do. I guess you're all quite familiar with it now, but as a very kind of high-level overview, it's a very big company in the semiconductor industry. We make lithography machines, hardware, software, and recently we start to add Julia into that mix. So a bit about myself. So my background is in physics and philosophy. So physics is kind of why I like Julia, I guess, and philosophy is kind of my perspective on this talk, kind of taking a step back, reflecting on what ASML has done with Julia so far, and seeing what we can kind of learn and adapt for the future for that. I started working at ASML almost 2 years ago, so I'm quite fresh, and I've talked a lot to different people in the ASML Julia community to get a bit more information about that history. It's been very interesting. I learned a lot in the past few weeks doing this. I would recommend it to everyone to actually talk to all these kind of key stakeholders, not just in ASML, also today it's really a great experience to meet all of the interesting people here. And I'm a frequent Julia Meetup Eindhoven visitor. I really like the community. It gives a lot of energy. And even when I was still very fresh into Julia, I felt really welcomed by those people. So a big shout out to them, and I would recommend everyone to visit such a meetup, but also start your own meetup if you're not close in this region. Then on the right, I tried to kind of assess my own Julia capabilities, which is not an official scientific tool, but I wanted to quickly kind of get you an idea about why you can't expect any heavy technical topics from me, because I'm not that heavy technical person. So I distinguished two kind of frames. So one is me by myself, very much a newbie, a bit of casual maybe, but a kind of average Julia believer. But then I'm lucky to be in a Julia community, which is very, very supportive. So if I kind of look at my history of Julia projects, I feel I got a lot of help from other people, and I did even some kind of developer small thing with some help from colleagues, and I'm more in the proficient than casual. But my belief also grows a lot with the people around me, so that's a good thing. Now, this slide, I'm going to kind of I'm just going to show it. This is the real reason that I'm standing here. These three people, I've kind of photoshopped it a bit because that is how it started to look in my mind. I think these three musketeers of Julia at ASML, that is the real reason to me why we've come so far. And I think many more people, of course, joined it in at some point. And I've talked to all of these three people, and they're great persons. I would recommend everyone to meet them. And they also said that they couldn't have done it without other people joining in. But they were united by a passion for Julia, and they identified some problems in ASML for which they saw Julia could be a solution. And I'm going to quickly go over them. I think you might have also seen these slides before, but for completeness, I'll still show them. So first, the kind of problem that they identified in ASML is the development time. So really creative research people, they come up with a new idea, they have a proven algorithm, often kind of shown some proof of concept in PowerPoint, and then they get the customer really excited, and then the kind of conversion into a real product. I know it says prototype, it was a typo, and I couldn't update my slide anymore. Anyway, sometimes also products keep on evolving, so you could argue that we still deliver prototypes to customers. I don't want to go into that discussion, but the time it takes before a prototype actually ends up as a product at the customer is so long that often requirements change, and it's really hard to keep on that excitement for that time. And one of the explanations for that is, you can see in this slide, is that there's a lot of tools. You can see all these arrows correspond to different teams, different people having to communicate, align, update, and with a growing organization, this becomes harder and harder. You constantly have to check if in every tool, every language, there's multiple languages here as well, things correspond, and you have to kind of, we lack the one source of truth. And that was something that they wanted to improve with doing Julia. Then the two-language problem. Only this week I realized that there's two ways to interpret the two-language problem. You can, of course, see it from a very individual level in saying that as a kind of, some people, they themselves work in multiple languages. They first prototype in one and then they convert it themselves. I think for ASML, it's so big and we have highly specialized people. It's also a lot about the kind of the distribution of different people that you have. So going from one language to another is not just rewriting the code yourself, it's also talking and explaining to someone else what you mean. And I think that is also something that we try to improve in ASML. Now, the first kind of historical things that had to be overcome before ASML actually kind of started working with Julia was to convince some managers, of course, and onboard new engineers in Julia who were not familiar yet, and set up an infrastructure and build tooling in and for Julia, which might not be a surprise, but okay. So first, I want to give an example. I dived into all of the old slides that were used at that time to convince the managers that Julia would be the best solution. And Jorge was really critical to me. He said, yeah, but actually these slides, they weren't convincing enough because then they were perceived as being too biased. And you can imagine if you have 3 people in front of you really excited about Julia and they show you these slides, then they're going to say, don't have the technical knowledge, but something must be off. This is looking too much in favor of Julia. So that was probably also the reason why many more of these kind of slides were added. I also had to add a note that things change, of course. It's already quite an old slide, so it's not representative. But this is the kind of discussions that went into that. There was a list of requirements and different solutions were compared. And yeah, I think it gives a kind of an idea. But at some point they managed to do it, and there was a pilot with some luck maybe, but also good argumentation and a lot of evidence given. So there was a pilot project in my department, my group, and the next challenge was to kind of set up a scalable inner source ecosystem. This is actually not my expertise, but one of the people from the 3 Musketeers, he has a blog, The Scientific Coder, I would definitely recommend it. And he describes kind of the decisions and the steps that were taken to set up this infrastructure. So first, it was about the repository structure. When I rehearsed this talk, I used one of the things in the blog is about that, how ASML used one single repository, some satellite packages. And I was at the satellite talk, and I realized that satellite packages has also a completely different meaning. But in ASML, it's not actual satellites, it's just some independent packages. But there was also a lot of thought that went into the types of packages, because of course, one of the things that is important to ASML is that we have a lot of departments with IP, and you can't just publish a package even internally, because then maybe some people would have access to information they're not supposed to have. So there's different layers of packages going from the open source to the inner source, and then for specific domains, which are a bit more restricted, dependent on your kind of information that you're allowed to access. And then also integration and deployment. That's also where still a lot of work is to be done, but I'll come back to that later. Then what I think they did really good in, at least in my department so far, and I think a lot of the departments that now look at how we work are really jealous of that, is to think about the developer workflow. Because Julia, it kind of invites a lot of non-developer people to also use it, and it makes it really accessible to use that. And they thought about the workflow for different types of users, and it really lowers the bar to start working with Julia. And then that kind of comes together in the full infrastructure with a lot of we have the luxury of being in such a big organization where there's a lot of support from IT and DevOps. And this kind of completes the whole design that was made for people like me, but also a lot of different users. So that is kind of what has already happened in the past. And now that brings me to kind of putting these accomplishments so far for you. So there's an internal ASML Julia community with 532 members. They're not all active members, but there are at least people that showed an interest, and this community is growing. And the next is the number of internal ASML packages. Of course, people have mentioned it frequently within the company. At some point, we'd also like to contribute more to the open source community. And I think Tom just mentioned in his talk earlier in this room that there are 4 on his list, and there's 1 more being developed within ASML. So slowly, we'll also get more to that point. And then the third one is the official trainings and boot camps that we have in the company. I want to go into that a bit more because that has also contributed a lot to where we are now, but it's also something we pay attention to in the future. Because actually, what we learned, I think at the start, there were some very kind of personal boot camps where there was an engineer from your own group, in my case, that would sit down with some people for a few days and they would pay a lot of attention to the types of questions that people had and the kind of background that they had. And for me, I had some coding experience, but I was not that used to having one certain kind of way of working. I was used to Python, but I wasn't kind of using that on a daily basis. So for me, it was really important to get some support with the setup at the start, which was there, which made it really easy for me to skip the kind of the steps you have to go through once and just start working on the language itself. Then there was a boot camp and a training, which was really good. It was split actually in some kind of more traditional trainings that you could just follow online for Git and the Julia basics. And then it would also go into the more domain-specific knowledge for ASML for my group. And after building those skills and that training a bit, there were some notebooks. I think this is also a great thing for ASML to start using more with new hires. I mean, new hires have to get familiar with the domain anyway, and it's a lot nicer to do that with interactive notebooks and actually useful examples instead of reading a document or having to separate the skills from the knowledge, the domain knowledge. And then the experimenting starts, and many people might not kind of go into Julia deeper after this, but it's great that for those who are interested, there's a lot more options after that. So the next steps would be to convert a script into a package and then add tests and write documentation. I know this, for a lot of people, this is an important step. You should not skip writing your documentation, especially if you share it with other people. But Julia also makes it very easy to kind of, once you have your tests in place, start to refactor and optimize your code. And then finally, at the right side of this slide, you can add your package to the repository and start contributing also to the open source community. That's the end goal, I think. But there's also a very different type of engineers that we need to think about how to onboard them in Julia. And that, I call it people with habits, but I have very specific C++ engineers in mind for this. I talked to some people in my team who are very resistant to using Julia. They say, I have all my nice C++, I studied for years to use this, why would I ever do something else? So the first advice that I talked to some people, and the first thing we kind of laughed about it, we said, we just need to give them some time. You can't expect to convince them with 1 or 2 slides. So I think, and I really like that Font showed it this morning, that there are some pages that explain what is Julia compared to other languages. I think that is very important to explain, because if you start using Julia as a MATLAB user or a C++ user, and you start to use Julia for what it's not maybe specifically made for, I think then it's never going to work out. So you need to kind of understand the mindset and the goal for which Julia was made. I have to admit that first, it now says experience Julia. First I had experienced how Julia is better, but I talked to one of the C++ engineers and he forced me to take it out. I said, well, I'll take it out, but you'll experience it if you start using it more yourself, maybe. And then the next is to collaborate. And that is, I think, for me, an important point, because I'm not necessarily not interested in learning how to code better, but I've always struggled a bit hard, because in physics, it wasn't the kind of the goal to code better, it was just the goal to get to a solution. And that was fine, because when I asked some people to give me tips, that was a bit hard. And now, what I really like about Julia so far is that I can just walk up to an actual software engineer or someone with a lot of Julia experience, and they can give me very valuable tips, which are really important for me to get further and learn more. But if I think about how I would do that using MATLAB, then a software engineer would never even look at my code because it's MATLAB. If you're used to working in C++, then how are you going to comment on that? And I think that is a very valuable thing that we can use a lot more. And I think when software engineers actually kind of are resisting a bit less and more open to seeing the opportunities there, it's really nice to start working in the same language and learn from each other. They can learn more about the domain that we work in, about the domain knowledge, and I can learn how to code better, which will, in the end, might even make their jobs easier if they end up with optimizing my prototype. And then, of course, again, write documentation. I've been lucky so far that my kind of technical skills are not that advanced. So far, if I need any help or documentation, I just go to the more experienced people around me. But I guess that they also at some point need some external help. And then I probably can't help them out. And then contribute to the language. I think that's also something that is very positive for ASML so far, that if ASML has a problem, then they can actually just talk to the people behind Julia and say which kind of suggestions they have or where they're having problems. And it's very constructive in that sense that maybe in the next Julia version, the problem might be fixed. On the next slide, I want to go into that kind of hypothetical world in which the two-language problem doesn't exist anymore. Because it sounds really nice, but it also sounds a bit scary, maybe. Like, I'm very used to having those two different roles, and with those roles, there are different responsibilities. And if that kind of line starts to fade, how are you going to make sure that those responsibilities are all kind of covered? And you're still going to have people with different preferences. So I think this kind of where I see that a lot of technical problems are resolved quite easily, or maybe not easily, but at least quite fast. I think the cultural change, all the kind of the habits that not just software engineers have with a certain language, but also the habits of how we work together, have to kind of slowly evolve together with this. And currently, at least within ASML, we start to have more of these conversations, like because before we would compare C++ code to MATLAB code, and if they gave the same result, then that was also a moment to kind of be really happy, because that's when your product is successful. But if you don't have that MATLAB and C++ code anymore, then yeah, if Julia is your source of truth, how are you going to notice it when there's a mistake somewhere? So that are the kind of questions that we now also start to talk about a bit more now that Julia on the scanner is starting to become a more realistic target. And I think from the people that I've talked to so far, there are various different kind of opinions about that. Because when I started preparing this talk, I thought, I'll just talk to all the experts and they'll tell me what the truth is. But that's not actually true, because maybe they will agree on the point where we are now, but they definitely do not agree on what they think we're going to be at next year. Some think this will never happen, and some are still really excited, like the 3 people at the start, about what might happen in the future. And then that's also where I'd like to kind of finish off. I have 3 main takeaways that I kind of learned from this exploration and talking to all of these people and my own experiences. The first one is that it's still a challenge, and not just a technical challenge. Also, for a big, rigid, sometimes organization like ASML, it's also a very much a kind of cultural challenge. We have to reflect on our way of working, on our collaboration, and the two-language problem itself is not just fixed by creating a new language which solves it. It's also you also need to adapt together with that technical change. The second one is time, because yeah, technical problems, to solve them takes time, but cultural problems also take a lot of time. And I think maybe for ASML, because we're so used to our common way of working, the time might actually be an advantage for us, because you can't just start working in a different way tomorrow. You always need to take small steps. And the third thing I want to end with, kind of an optimistic thing is also to celebrate where we already are. I think if I look back to 3 years ago for ASML, I wasn't there, but I've heard. It was a bit of a mess, and even just looking at the tools that they were using, that people were using, and seeing that there was no version control, maybe, or that there was not one source of truth, and it was also always kind of a challenge to find whether the tool you were using was still correct. I think where we are now with the infrastructure is already a big improvement. And I will always remember that at one point I walked into the office and there was a team, and they just finished the Julia project and they were wearing hats. And I was asking, they were wearing celebrations hat like on the slide. And I was asking them, so why are you wearing that? And they said, yeah, these are our delivery hats. We finished a major Julia project today. We're very glad that it's finished and it's a success. And I would recommend everyone to do that a bit more, to look back, see where you've come, look into the future, ask yourself some questions, but also really enjoy where we are now, because I think it's a big thing to be proud of. Thank you.
Thank you very much. It was a very nice perspective on the ASML journey. Are there questions in the audience after this? I see the one in the back in the middle, long throw maybe, but not quite.
Okay, so if I understand the direction you're heading in correctly, at some point you're going to have to solve the problem that there's a huge C++ code base and you're going to have to tie Julia code into it, have it actually function in the same, larger application or something like that. And that is something that can potentially drive the, like the two edges of the graph.
Wait, let me.
Yeah, that'll move those two camps further away from each other.
This one?
Yeah, exactly. And so I'm wondering, is that something you've already encountered or are anticipating, and in what way?
That these two are going to move, I'm not sure what you...
Well, so you have Julia code, but at some point it has to run on the machine or something, ideally. Yeah. And that means you have to tie it into a bunch of C++ code that already runs on there, because you're not going to rewrite all of it in one go, probably. And yeah, so you're going to have...
To mix the kind of the new Julia code.
Yeah, exactly. And I was wondering, how are you going to attack the cultural aspect of that? I mean, technically it can be done, but that's...
I see that Martijn... No, I mean, from what I see now, I mean, there's the strategy that ASML has is to kind of roll it out in phases. So that always has some kind of awkward phase in which you have to kind of merge the two and people start resisting. I think the strategy they took now is that they defined the phases quite good, in the sense that there's no real, I don't feel like there's a mixing of the cultures. There's some teams and some specific projects that are kind of in the future, trying to do the future part where Julia is not just used in the tooling, but also in the final product. And I think so far there are still some technical challenges. I think the binaries that Jeff talked about today, that's one of the issues that ASML has. But I don't think mixing those two is a problem in that sense. I mean, I don't know all the technical details, but from what I at least see, that there's quite contained new project for which you can do it, and they've looked into the architecture for the software that you can do that in phases and kind of only for the new products, because ASML is still a production company. I mean, we're not going to kind of start a new TrinScan just with Julia. It's always going to be kind of in small steps.
Okay, are there any more? I see a hand right in the back and one at the front.
Here we go, Chris.
Nice.
Nice catch.
Ah, here, yeah.
Yep. Hello. Yeah. So one question that I have is, so one of the things that we're seeing, say, in things like aerospace companies as well, is they kind of have this aspect where you have one group that is built to do deployment and one group which is built to develop out the algorithms. And before there was like MATLAB and Simulink was one group where they say, oh, we don't really code, we don't know how to code. The other one is putting things on airplanes and they're like very strict about what they want to do, right? And they're two different groups, right? Yeah. And so there's this aspect of some folks start to get scared when they start to hear of like solving the two-language problem, because like, well, if the first group actually learns how to code, then what happens to the second group, right? So are you seeing, so you mentioned a little bit about that. I was wondering if you could elaborate about that cultural aspect of, like, because I think culturally, we're going to a future where it's like, oh, everybody's going to be coding, right? Yeah. But how is that being done organizationally, right? You probably have like a software developers group, right? And if everyone else is developing software, how is this kind of culturally affecting that?
So, okay, let me see if I understand it correctly. I think at least one of the questions that I had is like, if this is the goal to have Julia on the scanner, does that mean that I get to write scanner code? Because I don't feel comfortable with that. I think there was a talk about the 1.5 language problem, where it's that there's still a big gap between like the Julia prototype and the Julia final product. I mean, it's not kind of just optimization, it looks completely different. And I think in that sense, I think initially, and that's also a question for like managers, how do you hire people? Like if they're all right in Julia, how are you going to make sure that some of them actually write twin-scan code and some of them are more the prototype people? Because it's not the same code. And I think there is also where I think the kind of slowly evolving culture is going to help a lot, because you're never going to kind of from this picture immediately go into the other one. And I think by kind of taking that process really slowly, we'll kind of naturally go into defining those responsibilities differently. And I think still people will have different interests. If you look at this picture, the kind of text balloons that there are, you're still going to have people that are more interested in kind of quickly doing some creative coding, and some people that are not interested in that and will be on the other side. And I think from there, we will gradually kind of figure it out. And yeah, sorry, I feel like I'm answering your question, but not having the answer, because we don't know yet. We will see in the future.
May I add to that? I agree with all you say. I just want to add, it's basically in the team of Myrthe, you see functional and software people in the same team. So there's no magic there. Yeah. You don't take away anyone's job. You make them complementary. You add. That's the thing. And the way how we deliver, that was in addition to the other question. If you go in a system that is basically written in C or C++, the whole mindset is we create binaries or libraries, just like we're using external libraries all the time. We now just make our in-house libraries that we can generate in any system that is able to call it, whether it's running in Java or C++. There's no magic behind it, but that is basically what we aim for. Yep.
I think also to add to that, because indeed it's true that I already work quite closely to a software engineer, and right now I've also kind of challenged my team in that right now sometimes I feel like we kind of define the specifications and then we throw it over the fence and they write some code. But if I slowly can understand more of the C++ code that they're writing, but still there's a kind of, it feels like it's the other side. And I was sitting with the software engineer for my team and said, well, if you will actually start using Julia code, then we can look at the same thing, and there's a lot more understanding, because you will have the common language that we now kind of lack. So I do kind of hope and believe in the idea that maybe you'll still not do the same job, but at least you'll be forced to communicate better about what you're doing.
I'd really like to recommend the scientific coder you mentioned, right?
Yeah.
The blog talks about this. I did promise someone at the back already that they could also ask their question. And then after that, I think we'll be...
Yeah, maybe it's a bit related to what was discussed right now. In the talk we gave, I mentioned that using Julia comes with a smooth learning curve. And I saw the slide where you kind of went through the onboarding, what the onboarding process looks like for people that are new to Julia. And well, it's awesome, but I think there's a problem in the community, in the Julia community right now, that's most people can get up to that point and then maybe get kind of stuck because when you're starting to talk about more advanced programming patterns that are particular to Julia and, for example, understanding traits and compiler intrinsics and these sorts of things, there's not a lot of documentation, let alone resources, educational resources on this matter. So my question would be, have you come across people that want to take this extra step? And if so, have you relied on a more, manual one-to-one mentoring kind of process to get them through this extra step, or have you been able to make a collection of more, official cookie-cutter documentation that can cover some of the more advanced sides to using Julia and using it well?
Well, I think that the way that ASML typically works on a project, you always have, like, I as a functional engineer, there's always an architect, or there's always kind of resource available, and I think that's one of the advantages. And I can imagine that at some point that kind of stops. Like, you can always go one step up to a person that has more experience or more knowledge, or maybe more resources. And I can imagine that at some point the documentation is lacking. But from how I understand it at ASML, that there's quite a lot of contact with also Julia people themselves and with people outside of ASML who have similar problems. And maybe now the solutions are not there or are not well documented, but I also believe that that has a lot to do with kind of the maturity and kind of that will naturally evolve if more people start asking these questions and share kind of their own experimenting and their solutions. I think that will every year kind of get better.
Okay, I think we're through on time, actually. So if you can give Myrthe another big round of applause.